Okay, everybody. So the last time we were together in the last section of this video, we just talked about, we kind of went through this whole discussion of where these 30, 60, 90, and 45, 45 right triangles come from. I know you guys got that. And then we realized that it would give us some really good information about the sine, cosine, tangent, all the trigonometric values for these special angles, because we can use these triangles as a guide. And so we realized when we were finding the sine of 30 degrees, that would be this right here. If we stood here, we know sine is opposite over hypotenuse. That would be the sine of 30 degrees in this case would be, we would get, let me get a pen, I'm sorry, x over 2x, and then that reduces to 1 over 2. So that's true anytime you're dealing with a 30-degree angle. And so now we're going to continue. So with that in mind, we're going to take a look at what happens when I do the cosine of 30 degrees, and that's adjacent, x root 3 over hypotenuse 2x. I'm going to reduce that and you get it, root 3 over 2. If I did the same thing with tangent, tangent is opposite over adjacent. That would be x over x root 3. Stay with me, chavalitos. I promise it'll make sense. So that's really 1 over root 3, but you know, mathematicians, we're not really into radicals in the denominator, right? So we take the reciprocal, no we don't, we multiply top and bottom by the square root of 3, and then we end up with the square root of 3 over 3, and that's what you're going to see here. Okay, so this is where all of these values come from. And of course, we know that the relationship, once we get those first three, the relationship with the next bunch is going to be a piece of cake. So the cosecant we expect to be the reciprocal of sine. So that's 2. The secant we expect to be the reciprocal of cosine, and that's going to be 2 over root 3. But you remember that we have to rationalize the denominator. So 2 over root 3 is going to become 2 root 3 over 3, because I multiplied the reciprocal by root 3 over 3. I hope this is making sense. And then over here, we're going to get the reciprocal of 3 over root 3. But if you remember, where did the 3 over root 3 come from? It came over 1 over root 3. So when I take the reciprocal of that, I get just root 3. Y'all with me? Y'all know y'all my friends. All right, so we can continue that whole process, and what you're going to get is this chart that, yes, I expect you to memorize. Not memorize, be able to divine yourself, if you want to think of it that way. So you should be able to do this chart. You should be able to make this chart by the given information. So 45-degree angle opposite over hypotenuse is going to be root 2 over 2. First we start off with 1 over root 2, then we get root 2 over 2. Same thing with adjacent over hypotenuse is going to be the same. And then tangent, what do you think tangent is going to be? It's opposite over adjacent. It's going to be 1 because it's x over x. Then we're going to take the reciprocal of each of those and we'll get these values. Then we'll start at 60 degrees and we'll do the same thing. The sine of 60 degrees is opposite over hypotenuse. The cosine of 60 degrees is adjacent over hypotenuse. And then we go on and we get the same thing. And you're going to notice some interesting patterns here. So I want you to keep those patterns in mind, okay? So I want you to take a look at these patterns and make sure that they make sense to you, and make sure that you're kind of seeing how this whole thing goes. So we'll talk more about it, but I just wanted to spend the time on it now because this is going to be super helpful later on. All right, so let's take a look at this situation. In example 3, we're supposed to find a missing side length of a right triangle. So here we have this. We've got this angle. You guys know how to do it. Write an equation involving sine, cosine, or tangent that can be used to find the value of x. Then solve the equation, round to the nearest tenth. Pretty straightforward. So I like to say you got to use what you've got, which is this 8 and this 30 degrees, to get what you want, which is this x. So if I'm standing here at 30 and I have the adjacent side and the hypotenuse, cosine is going to be the one that I'm going to use. So now I'm looking at the cosine of 30 degrees, and that's going to be equal to x over 8. Remember what the cosine of 30 degrees was up there? I know you probably don't remember it, but the cosine of 30 degrees is root 3 over 2. So instead of pulling out my calculator, I can really pull out a root 3 over 2 and go ahead and work it out. So now I know that 2x is equal to 8 root 3. That's me just cross multiplying, friends. Divide both sides by 2. I get that x is equal to 4 root 3. Pretty nice, huh? I guess I should have gotten that too, though, just by looking at it now that I'm thinking about it, because this is clearly a 30, 60, 90 right triangle. I'm sure one of y'all saw this and was like, why is she doing so much work? Well, there we go. Okay, so here's one where I can't do a 30, 60, 90 right triangle. We're going to solve this right triangle. Okay, so to solve a right triangle, you remember is to find all the measures of the angles and all the measures of the sides. So anytime you're asked to solve a triangle, you want to make sure and be able to relate six different things. And so those 6 things are these lengths. So first thing, I'm going to write down the measure of angle X is 35. The measure of angle Z is 90. I'm just putting the information in that I have. The measure of side Y, which is going to be XZ, which side Y is going to be 10. And so I'm looking for the other bits of information. So this shouldn't be too bad. First of all, I can find this angle relating the fact that all 3 of these angles must add up to 180 degrees. Therefore, Y, 55, 35, 90 is going to give it to me. Has to be 55 degrees. I hope that makes sense to everybody. All right, so now that we've come up with that, this should be a great place for us to use what we've got to get what we want. So in this case, as I look at, let's say, finding Z, I can use these 3 bits of information, the 35, the 10, and the Z. So I'm looking for the hypotenuse, but I have the adjacent and I have an angle. So that looks like cosine of 35 degrees is equal to adjacent 10 over Z. I like to make my stuff calculator ready, and so what we are realizing that every time we solve this, I could multiply both sides by Z, right? And then divide both sides by cosine of 35. If I wanted to get the Z by itself and up out of the denominator, I'm going to do this one time, and then you guys will see what happens. Basically what happens, the Z and the cosine of 35 switch places, right? Do you see that? So whenever I have a situation like that where the thing I want to solve is in the denominator and it's equaling to something else, it's like a fraction with it in the denominator, I know that I can switch it. So just looking at that, I know that this is really Z is equal to 10 over the cosine of 35. So with a little bit of calculator work, I get that Z is equal to approximately 12.02, which they asked to the nearest degree, so we're going to say just about 12, right? So Z is equal to about 12. And so if that's what I have there, then I have a number of ways to solve for X. So I'm going to put a 12 here, no, 12 here, and I need to solve for X. Now I could pull out the Pythagorean theorem, to be quite honest, right? And just kind of approximate the value. But I'm going to be honest with you, I don't like approximating approximate values all the time. I like to use as exact numbers as possible. So we remember that this angle right here is 55. If I want to find X, I'm going to use these 3 numbers. I think it's just a little bit easier for me to do that. And again, I'm going to be using one of the trig functions. This time I've got 55, 5 and sorry about that, 55x and 10, and this is the adjacent and this is the opposite. That's tangent. So I'm going to use the tangent of 55 degrees is equal to opposite 10 over x. You remember the trick we just talked about where you just switch those 2 values. So x is equal to 10 over tangent 55. And the final thing I'm going to do is use my calculator. I get that my answer is 7.007, which we're going to say is just about 7. So I'm finishing up with a 7 here, a 10, and a 12, and now I've solved this triangle. Here in example 5, we're asked to solve the triangle, find the measure of the sides to the nearest tenth, all of that's done, and the angles to the nearest degree. So the cool thing is that we have these angles on these sides already done. Now we just need to find the angles. And so what this is going to require is our inverse function. So if I want to find this angle theta, or the measure of angle A, I should write it that way. You see, I already had a bias. I'm writing tangent just because that's what I feel like doing. But really, I could have used any of the trig functions, particularly sine, cosine, and tangent, because our calculators are handy with those. So the tangent of A is 5/12. Do you guys remember how to undo this? What we do is we take the arc tan, or sometimes it's called the inverse tangent, and we take the ratio, and then we are going to get the angle spit out. Make sure that your calculator is in degrees when you're doing this. And so arctan of 5/12 is equal to 22.1, 22.2, I think it was, degrees. And so that's A, and they asked us to round it to the nearest degree, so we're going to call that 22 degrees. And so once we honestly get one angle, you know that this is 90 degrees. You guys know how this is going to go down. All we need to do is get this other degree, this other angle here, and it's going to be 90, because these two have to add up to 90. It's going to be 90 minus 22, which is going to give us 68. So honestly, we've solved it. We've got side A, side B, side C, angle A, B, and C. We're done here. Sometimes we can use indirect measurement in order to find measurements of things that we need to find information about. So here's this bridge construction. In order to construct a bridge across a river, the width of the river at the location must be determined. Suppose a stake is planted on one side of the river directly across from a second stake on the opposite side. At a distance of 50 meters to the left of the stake, an angle of 82 degrees is measured between the two stakes. So are you guys with me? So we've got a stake here and a stake here, and then we make a decision to put another stake in the ground, and we get that this angle is 52 degrees. By measuring this angle, we can find this length. Okay, fine. That's fine. Maybe we do that. So find the width of the river. So really, this problem is like all the other ones that we've talked about thus far, in that we're going to use a trigonometric ratio. We're going to use what we've got to get what we want. I'm at this angle. I'm looking for opposite, and I have adjacent. Hopefully you guys are thinking tangent. Tangent of 82 degrees is going to be equal to W over 50. Making it calculator ready, we get that W is equal to 50 times the tangent of 82. And with a quick push of our calculator, we get that the width of this river is approximately 355.76 meters. Our final example is example 7, and we're going to talk about the use of angle of elevation. So the aerial run in Snowbird, Utah has an angle of elevation of 20.2 degrees. Its vertical drop is 2,900 feet. Estimate the length of the run. You guys get it as usual. So the run that they're talking about is this length here, and so this would be the hypotenuse, and this is opposite, and we've got an angle. What uses opposite and hypotenuse? Hopefully you're screaming at your screen and you're saying sine, and not sin. So sine of 20.2 degrees is equal to opposite, that's 2,900, over h. You remember our trick. When we need to solve for something that's in the denominator, we can swap it with the thing that the ratio is equal to. So we get h is equal to 2,900 divided by the sine of 20.2. Using our calculator, we get 8398.5 what is this, feet that we're dealing with, and that says h, which makes me think height, but I really meant hypotenuse, which therefore is the length of the run. So this is referring to this. I hope this made sense, guys. I hope that everything feels comfortable. I know this was a long lesson. I don't like when they get this long, but I think it was some necessary information there. Let me know if you're having some difficulty, if there's some way that I can help you, if there's something we can do to talk about some of this work. Listen, take it easy. I look forward to seeing you and speaking with you soon. Bye-bye.